This is that Haber process. Remember that Haber process is that synthesis of ammonia. Real important reaction in chemistry, the Haber process. All right, I've got my reaction there. And now I'm going to start filling in information. It says a 2 molars of nitrogen is placed in a container. So if you're putting it in a container, that's probably the initial amount. It needs to be in atmospheres or molarity. It is in molarity, so we're good to go. I'm going to stress that because in a moment you're going to see moles. So it needs to be in molarity or atmospheres for the rise tables. Okay, so that's 2, and then it's in a container that already has 4 molar hydrogen. So that guy's going to be there. And then 5 molar ammonia. So everybody's got some numbers going on there. That's good. It says when equilibrium is achieved. So now the number that they're about to give me is going to go down at the E, and they are giving me that 2 molar of hydrogen is present. So it started with 4. It ended with 2, and I know it ended with 2 because it told me that. So I can figure out how much it changed. Can you see how much it changed? It was 4, and now it's 2, so it must have gained or lost. Well, it must have lost because it was 4, now 2, and so it lost a 2 molar. All right, so if this is a reactant and it lost, that reactant had to have lost. And if these reactants lost, we must have added product. I will tell you sometimes students mess this up because they go negative all the way across. Some students go positive all the way across, so just be careful. All right, now this one's interesting because now we've got some weird proportions, and for you, when it's like 1 to 2, our brain's like, oh, I got that. But now it's a weird proportion. For every 3 of those is 1 of those, and so some of you can see that proportion and some of you cannot. So I'm going to go right here. This is where it matters, is right here at this C. So now I could do stoichiometry if I wanted to. Molarity, remember, is moles divided by liters, so a big M is basically moles divided by 1 liter. So I'm going to go set this up, and you don't necessarily need to do this if your brain can see it, and a lot of times your brain can see them. 1 to 2, a 2 to 4, a 1 to 3. Your brain sometimes can see those ratios. Your brain doesn't see as well when it's like a 25 to 19 ratio. And your brain's like, oh my gosh, what in the world am I going to do with that? So I'm going to do a proportion, and I'm going to do for every 2 moles per 1 liter. Oh my gosh, that's molarity, is it not? Molarity. For every 2 molarity of H2, because that's the guy I know, right? I'm going to figure out how much N2. If I can ever get this thing to quit spinning, I will write here in a moment. I'm going to set up a dimension analysis table in just a minute. Alrighty. So I don't need to mess with liters. It can just stay there. What I'm going to do is a mole-mole ratio. And again, some of you can see this. So for mole of H2, I'm going to figure out moles of N2. Oh my goodness gracious. Look at that. Okay, so moles of H2, moles of N2. So where are these numbers going to come from? They're going to come from that balanced equation. And in front of hydrogen, there's a 3, and in front of nitrogen there's a 1. And so again, some of you could have seen that this is going to be 2 over 3. So 2 over 3 is going to be, it's a bunch of 6 repeatings, and so I'm just going to go 0.67. Not going to do 3 sig dix for that. So I'm just going to go 0.67. So this is going to 2/3 basically, right? So it should make sense. 1 to 3 and 2 to what? So that's going to lose that. So this is going to get us a 1.33 because I subtract those. So see how the proportion 1 to 3 proportion is going to go on there. I'm going to do the same thing. 2 moles of H2 per 1 liter. You don't have to put the 1 liter, but that's just going to keep it molarity. And that's going to get us moles of H2. And then I'm going to look for NH3. So then you're going to get moles of NH3. And where are these numbers coming from? For that mole-mole ratio, for ammonia it's a 2, and for hydrogen it's a 3. So that is 4 divided by 3, which is 1.33 repeating. So we'll just go out 2 decimals, will be just fine. Left my little unit off of that guy. Well, probably should have because it's going crazy. All right, now look, I'm going to add. So I'm going to get 6.33 m. Do you remember what our goal was? Our goal was to get down to the E because we were looking for that K. Because I didn't know the K, I knew that I wasn't going to have X's in my table. So now our K is going to be our product number, so 6.33. And that is going to be squared divided by our reactants, 1.33. And that is going to be to the first. You don't have to write to the first. And to the third. And you should be getting a value of 3.8 if we did 2 sig digs on this one. 3.8. All right. Hopefully this proportion thing made sense to you. All right. Sometimes you just can see them because many times it's just a 1 to 2 ratio.